If we are given the reaction quotient Qc and equilibrium constant Kc of a reaction at a particular temperature, we can compare them to predict the direction of the reaction. Given Kc, we can calculate a reactant concentration or product concentration at equilibrium. If we are not given Qc directly, but are given initial product concentrations and initial reactant concentrations, we can calculate Qc. With Qc and Kc, we may guess the direction that the reaction will go. There are three scenarios. First scenario, when Qc is smaller than Kc, the ratio of initial product concentrations to initial reactant concentrations is small. This implies that the numerator, which is associated with product concentrations, is relatively small, and the denominator, which is associated with reactant concentrations, is relatively big. The goal is to become Kc. To do so, the numerator must grow larger and the denominator must be reduced. That is, the relatively low level of each product has to become higher and the relatively high level of each reactant has to become lower. Thus, to achieve equilibrium, more reactants must be converted to products. The system proceeds in the forward direction. Second scenario, when Qc is equal to Kc, it means that the initial concentrations are the same as equilibrium concentrations. Thus, the system is already at equilibrium. Third scenario, when Qc is greater than Kc, the ratio of initial product concentrations to initial reactant concentrations is larger than Kc. That is, the relatively high level of each product has to drop and the relatively low level of each reactant has to be raised. So to reach equilibrium, products must be converted to reactants. The system proceeds in the reverse direction. When a reaction moves from left to right, it uses up reactants and forms more products. The numerator in the reaction quotient becomes bigger while the denominator becomes smaller. Qc therefore increases until it is equal to Kc, at which point equilibrium is established. When a reaction moves from right to left, it uses up products and forms more reactants. The numerator in the reaction quotient becomes smaller, while the denominator becomes bigger, giving rise to a decrease in Qc until it becomes equal to Kc when equilibrium is established.